Morning, everybody. It's Chris here. Welcome back to 30-Day Excel Analyst. This is day 21, and this is the start of really useful week. Yes, I've got a bundle of tools and techniques this week. We've got 3 or 4 sessions, and it's techniques that didn't fit into our 4 main categories of Excel practice, but it's stuff that's really useful. We're going to talk about formatting techniques. We're going to talk about workbook structure and layout. Today, we've got a quirky but super useful session on how to generate random data in Excel. Yes, if you've ever had to test a model in Excel, if you've ever had to test a data analysis tool that you built in Excel, you might have had to generate a random data set. If you don't know these techniques, it's going to take absolutely ages. This is what we're going to cover in the next 20 minutes or so. And this is really useful week. This is day 21 of 30-Day Excel Analysts. We're aiming to transform your analytical toolkit in around 30 days. So we're going to do a quick course summary because what's happening today is we're changing tack a little bit. We're changing tack from the solid technical stuff and we're moving into, how would you say, some more miscellaneous stuff. And then next week, some more conceptual stuff. Yeah, the last week of 30-Day Excel Analyst is entirely conceptual. Those conceptual skills are absolutely critical to your career as an Excel analyst. We're going to cover those next week. This week, more of a miscellaneous week, but we're getting out of the technical zone, getting into a more strategic and, as I said, a conceptual zone. So look out for that. But we are going to do a course summary. So never forget this, guys. We're going to learn about the concept of holistic thinking. Sounds very cheesy, but it's just so useful generally. Try to think holistically about what's going on. So we always start from the whole and we work to the parts. We don't start from the parts and work to the whole. That's what overly technical people do. That's what we're trying to guard against on 30-Day Excel Analyst. So what's our overview? Well, we say in Excel, people are only trying to do one of 4 things. You can go back to week 1 on 30-Day Excel Analyst, where I present my ongoing research project to create a general theory of Excel usage. Generally, what are people, managers, professionals like you actually trying to do in Excel? This is what I'd like Microsoft to do. They've got more resources than Tiger Spreadsheet Solutions. Rather than knocking out another formula that's going to improve Excel by 1%, knock out a general theory of Excel usage so people know generally these are the skills I need to learn. That's what I'd like to see Microsoft do. Anyway, we talk about data management, data analysis, modeling, and automation. Now, I've put these slides in today's slide pack. I'm not going to go through them now. I've been through them so many times. But it's really for you to get you back into that overview, get you out of technical zone. Last week was a very tough technical week when we were doing automation with VBA. So we need to step out of that technical mindset and get into that conceptual kind of overview area. So we've got data management. Here's our 23 data management techniques. We covered these in data management week. Got our data analysis week stuff as well. Pivot tables, Excel formulae. All incredibly useful. Excel modeling basics. We had Excel modeling week, of course, got our big 5 modeling formulae and an array of other useful stuff there. And last week, as I said, we did Excel VBA automation week. So it was quite a fast and furious week, wasn't it? Because I was trying to cover a lot of ground. I hope you got plenty out of it. And as I said last week, we've got many learning resources about Excel VBA. If you go to one of the videos from last week, look in the video description below. That's what made this channel successful, our Excel VBA content. So if you enjoyed last week, you will love that. So make sure you check that out. So from here to the end of the program, what's it going to look like? Well, I've got our schedule here. And you can go ahead and download these slides, by the way, as always, if you can't view them very easily. And you can see today we're covering how to generate random data in Excel. We're going to cover keyboard shortcuts, tips and tricks, Excel formatting, making your spreadsheet look good, and effective workbook structure and layout. I found all of these couldn't really fit into one of the 4 skill areas we just mentioned, but incredibly useful. So I've called it really useful week. And this is where we are. This is what we're going to learn this week. And a good thing about this week is all of these sessions sit nicely on their own. So you don't need to learn a load of other stuff. You can view any of these sessions independently. I think you're going to get a lot out of it. And just on a practical note, for the live squad, Wednesday, we're going to start at 8 o'clock. I think we're going to start at 8 o'clock. Can't do 10 o'clock at Wednesday. On Wednesday. So just watch this space for the precise time. It's likely to be 8 o'clock UK time on Wednesday. Then after that, next week, I call it from analyst to consultant. This is where we're going over that conceptual stuff. So you don't want to be sat behind a computer your whole career. You want to be able to engage with managers in your organization. You want to be able to grow your business. If you want to be an Excel freelancer, you want to be able to create good content. In order to do that, you've got to be viewed as a kind of trusted advisor to people, more a consultant than an analyst. And that's what we're covering next week. This is all strategic. It's a business strategy. How do spreadsheets fit into business models? How can you think about a whole industry and how spreadsheets might help? We're going to cover a methodology for doing a whole analytical intervention in Excel. So if a company contacted you and said, listen, we're not sure how we're using Excel spreadsheets, we're not sure if it's the best way, we want to get more value out of Excel. I love it when people phone Tiger with that question. We have a methodology that we apply for looking at a whole business and finding opportunities to apply Excel. That's just a taste of what's coming up next week, from analyst to consultant. And then the week after, how to build a career as an Excel analyst, and then the course overview. And just bear in mind, we do have a rest week here. So we're going this week, and then we're having a rest week the week after. And then we'll get into from analyst to consultant from the 16th of October. So back to really useful week. A really boring thing you might have to do in Excel is to generate random data. So let me know if you're watching live, guys. Leave me a comment in the chat. Have you ever had to generate random data in Excel? Leave me a comment below, guys. If you're watching on replay, I'll get back to you there. I want to help you get as much value as possible out of the 30-day Excel Analyst program. So if you are in that situation where you need to generate random data, Excel provides us with some options. There's some formulae that we're going to go through now that you absolutely need to know about if you're generating random data in Excel. And there's some combinations of things that are going to take it to the next level. So we're going to cover some of the basic formulae. Run between is the most obvious one that comes to mind, but only generates really a very specific thing, what we call uniformly distributed discrete numerical data. Uniformly distributed discrete numerical data. That's what run between does. Kind of a cool formula, but usually you don't want uniformly distributed data. You might not want discrete numerical data. So you need to be able to do a bit more than that. The norm int function here, so this allows us to access the normal distribution, which is that bell curve distribution that might, give you nightmares from back in your A-level maths days, like it does for me. But we're going to see how this statistical distributions can actually help in a really practical way. Statistical distributions only exist because they're really helpful. Yeah. It's just for decades, they haven't been very well taught. And that's why people like me, and perhaps you get nightmares about them. But this formula is incredibly useful. We're going to dip into this formula quickly, and then we're going to look at the random formula and how we can combine that with a probability table to create a cool custom probability distribution. So through the program, we've been working with some data sets. These data sets I generate myself using random data. Okay. So let's get into this file. Let's go ahead and learn some techniques now. So rand between, rand array we might touch on, but rand between, let's go ahead and do it. So you want to generate a random data set, and your data set has specific attributes. Specifically, the numbers are discrete. So you want whole numbers, and you want what we call a uniform distribution. A uniform distribution. So it's the same likelihood of each number occurring. The same likelihood of each number occurring. So let's say rand between 1 and 10. Let's go ahead and generate, 100-ish random numbers. So I'm holding down the shift and page down key on my keyboard here, which is just the down arrow, holding down the shift key now. And I can see Excel is telling me how many rows I've selected there. So let's go for 100 and Control D here. Later in really useful week, by the way, we're going to cover Excel shortcuts, maybe even tomorrow. So all of these shortcuts we're going to cover in a particular session. So suddenly we can see we've got our randomly generated data, random numbers between 1 and 10. Pretty cool. Let's take a beat and let's just note what the behavior of these random numbers is. Every time Excel calculates, so every time you put a value in a cell, for example, Excel is going to calculate. You can also hit the F9 key on the Windows PC to force Excel to calculate. You can also go to formulas and click this button here in the top right. That's going to force Excel to calculate. So something to be aware of with randomly generated data. And we'll at least talk about how to mitigate this before the end of the session. One thing to bear in mind is it's going to keep regenerating, because every time Excel calculates, Excel is going to kind of rerun this ran between formula, and Excel is going to go and get some more random data here. But let's prove to ourselves the distribution of this data. So I'm going to go for COUNTIF from Data Analysis Week, the most useful formula in data analysis. And actually, I'm going to go ahead, do something a bit fancy here. I'm going to use the sequence formula, which is a formula that's available in Excel 365. If I say sequence 10, and then comma and another comma, 10 rows, 1 column, starting at 1 with step 1, that's going to give me a sequence of 10 numbers there. You could just type in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. More likely, I'll do it like this: 1 plus 1, using that formula 05 plus 1, and then Control D to copy this down, the requisite number of rows. Anyway, that sequence formula is pretty cool. Control C, Control VV. Now, what I'm trying to do here is prove that we have a uniform distribution. So now I've got those numbers in: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can use COUNTIF. Now, for COUNTIF, I need a range and a criteria. Excel is saying, what numbers do you want me to look at? And the criteria is, we want you to count the numbers, the cells that conform to this criteria. So we're saying to Excel, look at range M5 to M104, and we're going to fix that using the F4 key, of course, comma, look at the range M5 to M104. Tell me how many cells have a 1 in. Okay, so we can hit enter now, and it's 13. Not too far from what we would expect. We've got 100 numbers, and then we've got 100 numbers, and we've got the ran between formula giving us a value between 1 and 10. So there's roughly a 10%, well, theoretically, exactly a 10% likelihood of any of these numbers. So I can hit the F9 key here, making Excel recalculate. And you can see there's quite a lot of variance there, isn't there? But you can see this is how the ran between formula is working. Let's validate this. Alt and plus at the bottom here. Alt and plus, and that's going to add everything up, and I can see we've got 100 randomly generated numbers there. Okay, so that allows us to randomly generate numbers on what we call a uniform distribution. What you'll find is if you increase the value of this data set, I'm going to go ahead and do this quickly, actually. So I'm going to increase the number of rows that we're looking at here. So I'm going to look at another 900 rows. That's going to give us 1,000 numbers here. If you increase the size of the data set, what are we going to find in terms of how we're counting these numbers and how close the real world occurrence is to that theoretical occurrence? So we're saying it's a theoretical 10% occurrence for any one of these numbers. So what's going to happen as we increase that data set? What we'd expect to see is the real world occurrence gets closer to that theoretical occurrence. So I can adjust our formula here. For the whole data set, and you could have tabulated this data, of course. That means the formula probably would have automatically expanded there if you had an Excel table. Control D here. Now, what you can see now is these numbers are closer to these to the theoretical likelihood, which is 10%, of course. So just something to bear in mind: the bigger the data set gets, the closer to that theoretical distribution that you're likely to get. Okay. So ran between, just a basic one. It's not going to help us in all situations, but it might help you in some situations. So what if you're saying, well, Chris, I'd like that bell curve distribution for my data. I can't get it with ran between. So what might my options be? I would look at this norm-inf formula, norm-inf, which means the inverted normal distribution. Let's not worry about the why it's inverted or anything like that. It's the normal distribution. So it's that bell curve shaped distribution. So if we wanted to return a data set that conformed, broadly speaking, to that bell curve shape, let's go ahead and try to do that. So how might we do that? Well, let's suppose we want to return a data set that's kind of similar to this data set, values from 1 to 10. But obviously the shape of the data is going to be different. But if we wanted to do something similar to that, how would it work? Well, we've got to use this RAND formula to begin with. let's go ahead and cover what this is. So this rand formula is going to give us a random number between 0 and 1. A random number between 0 and 1. So if you've got a very specific situation, you want random numbers between 0 and 1. That's going to be very helpful. Control D here. You can generate as many as you want, of course. It's very useful when we're generating random data because a value between 0 and 1 we can put into a probability distribution. As I said, haven't got time to go too deep into the explanations here, but the probability distribution, all it does is it divides up the distance between 0 and 1. Divides up the distance between 0 and 1 because we've got a normal distribution here. There's more chance towards the center of the distribution because the numbers are higher there. The curve is going up there. Now, before the end of the session, we'll look at how to generate a custom probability distribution too. But this is what RAND is doing. We're taking that distance between 0 and 1 and we're putting a random number in. This is what we're called sampling the distribution. We're putting a random number in and we're getting kind of a real world output, a real world number that makes sense in our situation out of the distribution. Okay. So let's suppose we want to generate a normally distributed data set that's, not dissimilar to the first data set that we've created using RAM between 1 and 10. So how to do that? Well, I'm going to go ahead and create 1,000-ish outputs again. So holding down on my keyboard, it's the control and the function key here. And then Control D, bring those formulae down. So I've got 1,000 RAND formulae now. Now, what do we need to do? We want to put these RAND formulae, which is just a value between 0 and 1, a decimal specifically between 0 and 1. What are we looking to do? We're looking to put that into our probability distribution, and the Norman formula is going to do the hard work for us. So probability, that's our value between 0 and 1. Then we've got mean and standard deviation. So can we remember what we mean by mean from data analysis? When we did our basic data analysis in Excel, a mean is an average, of course, and the mean average is a specific average. It's different to mode and median. Head back to data analysis week for a more detailed explanation there. But if we want a data set and we want that bell curve to be peaking around the value of 5 because we want values between 1 and 10, we can put 5 in that. We can put 5 in as the mean. You can put whatever value you want in there. And then finally, standard deviation. So another one of those scary statistical words, but standard deviation is how dispersed is our data? How dispersed is our data? So if we're using the normal distribution, a small standard deviation is going to bunch the data around the bell. If that makes sense, the data is going to be bunched up around the bell. If we have higher variance, the data is going to be more spread out. Because remember, all standard deviation is we're taking the average of the data set and we're measuring for each data point, we're measuring the distance from the mean. The deviation, then we're taking the averages of all those distances. That's all standard deviation is. I wish somebody explained that to me at the beginning of my master's degree because I was terrified of statistics. I almost failed my whole master's degree. I would not be here if I hadn't got a condonement from my university because I was so bad at statistics. No one explained to me the basic concepts with real world application. Anyway, I'll go and book a therapy session. Let's get on with this. So if we say standard deviation 2, the average distance from the mean, which is 5, is going to be 2. So that's going to give us this kind of distribution. And we're going to measure this distribution in a second. I'm going to put a couple more columns in here. Okay. So this is what we've got. And now what we want to do is prove, we want to prove what the distribution is. Okay. So here we've used COUNTIF. Now, where does COUNTIF work? COUNTIF works where we have discrete data. If you're using text, COUNTIF is great. If you've got numerical discrete data, so you're working with whole numbers and you can guarantee what those whole numbers are, then you can also use COUNTIF. What are we going to use here? We've got our RAND formula, and then we've got our outputs. How can we analyze this data? Can you go back to data analysis week? Can you remember? We can use the frequency formula here to analyze this data. So once again, we're going to go 1 to 10. Just going to use that simple addition formula this time. And because we're using frequency, these numbers, they define the bins, what we call the bins, because with frequency, we're going to create some bins, which are just distances between numbers. Then we're going to count the occurrences, the number of numbers that fits into each bin, if that makes sense. Now, these are upper bounds. These are upper bounds. So any value, Alt-HW here, wrap the text, any value less than 1 is going to fit into this row. Any value 1 to 2 is going to fit into this row until we get down here. Any value 9 to 10 is going to fit into this row here. So if we've got this set up, we can then use the frequency formula. Difficult to set up frequency. We can go back to data analysis week. You have to select all of the cells you want frequency to go into. Then we can say frequency, hit the tab key, open the brackets. So the data array, Excel is saying, where's the data that you want me to analyze? So we're going to go ahead, select it, Control Shift down. Got to hit the F4 key, 1, 2, 3, $4 in there. Then the bins array. So Excel is saying, where have you defined those bins? We have to define those bins using single figures. Those single number inputs, they become the upper bound for each bin. Hit the F4 key again. Then the magic thing we've got to remember with frequency, we hold down Control and Shift. So I'm holding down Control Shift and then hitting Enter. And I can see the frequency formula working there. I'm going to go ahead and confirm this with our test, Alt and plus at the bottom. We've got 993 there. Okay, I was hoping that would be 1,000. So it might have been a bit wrong there. We've got 999. So I'm just wondering if I change this to 0. 1, 2, 3. Okay. I'm just wondering why we haven't got... maybe some of these numbers are more than 10 or less than 0. I'm just not going to worry too much about this. Just going to use a max and min formula here. So the minimum number in this range is less than 0. But that should be okay because that should fit into this category here because it's less than 1. Is the maximum number more than 10 here? And we can see the maximum number is more than 10 now because we're using frequency. That maximum number is going to be outside of our upper bound here. Interesting. So what if we wanted to tweak that distribution to bring the value into our range below 10? What would we do? We can go ahead and just adjust the variance here, adjust the standard deviation, hit Enter, and whoops. And then we're going to copy this formula down. Now it's standard deviation 1. What we can see is our data fitting into our frequency range there. So now we can do a quick chart. We can illustrate this. I'm going to insert the data. Select the data. I'm going to insert a column chart here. It's going to look something like this. We can delete this series. If I can just select it, we can delete this series. And now we can see a very nice illustration. That's the power of frequency, a nice illustration of our data here. If you hit the F9 key, all of those random numbers are going to regenerate and we can see the chart dancing. So this is how you make Excel dance. We can regenerate those random numbers. That's going to sample the distribution again. But you can see because we've got a decent sample size here, we've got 1,000 data points. It's all pretty consistently sized there. Right. So if you wanted, how would we say continuous numerical data and you wanted it in a bell curve shape, the norm-inf formula is going to help you there. Cool. So perhaps you're saying, well, Chris, I like this idea. I like this idea of a probability distribution, but my data doesn't conform to that bell curve. Yeah, could be any kind of data set. Who knows? Doesn't conform to that bell curve. So I want to have some control over this probability distribution. Okay. So we can go back to the dog data for this, and let's take, for example, let's say you want north, south, east, or west, which is what we've got here in the kennel column, but you want more probability for north. Yeah, you want north to be 60%, and then the others to have roughly a similar probability. Now, you could have any situation, but you want some kind of custom probability distribution. We've got to go ahead and build that distribution. Now, the way we do it is like this. So I'm going to say 0, 60. Let's go 0 to 70, actually. 0, 70, 80, 90, 100. Now, these bounds, they're different to the frequency bounds because we're going to use VLOOKUP here with VLOOKUP with approximate match. These are lower bounds. So 0 to 70. So thinking about that distance between 0 and 1, 0 to 0.7, that's going to be taken up by north, because we want north to be our maximum probability. And I should have written these as probabilities in the first place. So let's say north. These are now becoming lower bounds. So anything between 0 and 0.7 is going to return a value of north. Then we've got south, east, and west here. We can still see the chart dancing over on the left. That's because every time I'm doing an input, I'm making Excel calculate, and these random numbers are regenerating. Okay. So you need to set up a probability table, something like this. Now you can see I've got 4 options. You could have 2 options. You could have 200 options, whatever works in your situation. This is how to generate that custom probability distribution. So we're going to go for the same idea here. We're going to have 1,000 outputs. So I'm going to generate 1,000 random numbers. So shift function and the down arrow on my laptop here is allowing me to do this. Let's go to 999. I think we've actually done. So control D, 999 random numbers. Then this is where the magic happens. We're going to use VLOOKUP here. Now, VLOOKUP with approximate match. We've already covered on modeling week. We covered VLOOKUP with an exact match. VLOOKUP with an approximate match. What does it do? It's going to take numbers like this. It's going to take single numerical inputs and make them into ranges. Yeah, it's going to make them into ranges. So 0 to 0.7, it's going to make that into a range. 0 to 0.7, then it's going to return the value north. 0.7 to 0.8, it's going to make a range and return the value south. 0.8 to 0.9, VLOOKUP is going to make a range in the background and return the value east. 0.9 to 1, Excel is going to make a range in the background and return the value west. This is what VLOOKUP's doing. It does a lot of heavy lifting when we use VLOOKUP with approximate match. You have to have these numbers set up. These numbers have to be in ascending order. So you have to have the smallest number at the bottom and the biggest number at the top. For what we're doing here, custom probability distribution, it's always 0 to 1. A probability distribution just divides up the distance between 0 and 1. We discussed that idea in relation to the normal distribution. This is a custom probability distribution. That's all we're doing. Just envisage that distance between 0 and 1, and we're chopping it up. How you chop it up, you can do what you want, however it works for your situation. So our lookup value, it's going to be that random number between 0 and 1. You can see how important the RAND formula is in random data generation in Excel. The table array got to be accurate here. So you've got to have this set up. You've got to have your numbers, which are becoming the lower bounds for those ranges. They've got to be in the first column. They've got to be to the left of your outputs. If you switch these columns, this isn't going to work unless you went and used XLOOKUP or something. Don't get into that. Have this set up and use VLOOKUP. So this is our table array here. Once again, putting in those dollar signs because we want that reference to be fixed when we bring the formula down, comma, column index number. So which column in our table array, as specified in the previous component of the formula, which column contains the value that we want the formula to return? Well, it's not the first column, is it? That's just our decimals. It's the second column here. So 2 there, and then crucially, range lookup. So you're probably used to building VLOOKUPs like this. That's going to work with discrete data. Here we're using continuous data, so we want a 1 there. You can also type in true. This should make the magic happen. So here we've got 0.024. So that fits into this range here between 0 and 0.7, and it's going to return a value from the row at the top of the range. If that makes sense, that's going to return a value of north. Going to double click here. So here we've got 0.80. So that's going to fit in between 0.8 and 0.9, return a value from the upper of those 2 rows. That's going to return east. Here we've got 0.97. 0.97 is between 0.9 and 1. That's going to return that value of west there. Once again, if you hit the F9 key, Excel is going to regenerate. But what do we need to do now? We need to validate the distribution of the data that we've generated. I can see lots of norths here. That's reassuring, isn't it? Because north has a 70% chance, which is much more than the other likelihoods of the other outputs there. So that's reassuring. But how can we be sure about this? Well, we can go ahead. Just going to put a couple of columns here. In here, we can go ahead and use COUNTIF now, because we can use COUNTIF because the outputs are discrete data. We've created these text outputs. They're discrete data, so we can use number one formula in data analysis, which is COUNTIF. So more practice. Excel is a skill. We know that from the Excel meta skills. More practice, putting together a COUNTIF formula. Got those absolute references in. And then I want to count the norths here, 692, Control D, and then Alt and plus at the bottom. What should this number equal? If my formula is accurate, that number equals 999, because Control Shift down, we have 999 outputs there. Let's go ahead, complete this process, because we've got our data nicely prepared and laid out. It's very straightforward to put a chart in. We're going to show, shall we have a cheeky, let's have a cheeky pie chart. Actually, I am partial. I am partial to a cheeky pie chart. And we can see now, once again, hit the F9 key. We can make Excel dance, but you can see not changing that much, not changing that much. That's because we've got a good sized data set. And as the data set gets bigger, you kind of revert to the mean, if that makes sense. And we can see that pie chart changing, not changing too much. Okay, just to clear up a couple of points before we finish here. So if you're watching live, guys, get a question in the chat. Very happy to answer those questions. What would we do if you didn't want these random outputs to change? You know, that's very likely you don't want the random outputs to change. Well, you've got some options here. Firstly, you can just convert these to values. So I can go Control Shift down, Control C on the Windows PC, Control Alt V and V. And you can do this by clicking through the ribbon, of course, convert those to values. I can see we've lost our VLOOKUP formulae. We've converted those to values. But then we've lost our mechanism, haven't we? We've lost our data generation mechanism. So the magic can happen when you combine this with VBA. Combine this with VBA. Say to VBA, you could just record this using the macro recorder, as we did last week in Automation Week. Say to VBA, take these cells, go and copy them somewhere and paste in the values. Copy them somewhere else in the workbook, paste in the values. Then you can have a button at the top there saying generate random data. That's a great way to retain your data generation mechanism, your probability table, and particularly that VLOOKUP formula. Retain the data generation mechanism and have some fixed values that you want to use for whatever your purpose is, whether you're testing a model, testing a data analysis tool you've built, creating training materials, creating Excel videos for YouTube, whatever it might be. This is it, guys. This is how to generate random data in Excel. We've been through ran between, a nice starting point, but you know, not super useful. Norminf allows us to generate that bell curve shape data distribution. Then we've looked at how to create a custom probability distribution. You could create any shapes distribution, of course, how to create a custom probability distribution using a probability table and using VLOOKUP. Fantastic. So that concludes that session on random data generation. Any questions, guys? You can put them in the chat now. I'm just going to say hello to everybody. Good morning, Jim. How are you doing, my friends? Good to see you. Arnie's with us now. Arnie says Australia has changed now because of daylight saving time. So even later at night, Arnie. Well, thank you so much for tuning in. So what time is it now that you're tuning in, Arnie? You'll have to let me know. Bert is tuning in. How are you getting on, Bert? Good to have you with us. Marcus tuning in as well. How's it going? Marcus, I think you left a comment on our social media this morning. I had a great comment on YouTube over the weekend. Somebody just saying, I think Excel is terrible to work with. It's quite a random comment because it was on one of our really old videos. So it seems that someone's gone through a load of our old videos just to tell us how annoying Excel is. Anyway, it's up to you what you do with your weekend. It's up to people what they do with their weekends, isn't it? Kieran, how you doing? Good to see you. Merrick is with us. How's it going? Roger tuning in as well. So Roger got Members Monday later, of course. Hope to see you for the Members Monday session today. And the General tuning in. General, I heard it was your birthday over the weekend. So happy birthday to you. Hope you've had a good time. So guys, that concludes the session on random data generation, something I have to do all the time. Hopefully today's session is going to help you in your career as an Excel analyst. We will be back tomorrow for more from really useful week, 10 o'clock UK time. Hope to see you there.